Welcome to All This Math. This is Professor Parker, and today we're going to solve a logarithmic equation. That's what we're going to do today. All right? So, hope you got your paper and pencil ready, or your pen, whatever, and ready to go in. All right, so this is a logarithmic equation, right? We have a left side of the equation and a right side of the equation. And we have different information on both sides of the equation. So let's first look at the different component parts of a logarithm and a logarithmic equation. This 8 right here is called your base. That's your base. This expression right here in the parentheses, this binomial, x plus 3, that's referred to as an argument. All right, that's called the argument. So memorize that. This right here will be the exponent or the power, right? Because when we solve a logarithmic equation, what we're going to do is we're going to convert it from a logarithm to an we're going to take it out of logarithmic form, which is what it's in now, and put it in exponential form, because exponential form is the inverse of a logarithmic form. So we're going to rewrite this as the base, which is 8, right? So we write this as 8. And again, this is the power or the exponent. So what this means is that this number raised to this power is equal to this right here, the argument. So this number, which is 8 in this case, raised to this power, 5/3, and don't worry, an exponent can be a fraction, we're going to break that down too, is equal to this expression right here. So we got 8 to the 5/3 power is equal to x plus 3. All right, so now that looks a little bit more familiar, a little bit more like some things that we might be used to from Algebra 1 or Algebra 2. All right, now, again, we're trying to solve an equation, so we're trying to isolate x. Always keep in mind, that's your end game. No matter what the equation looks like, your goal is to get x or whatever variable it is by itself. All right, so I want to get this x by itself. That means on the right side of the equal sign. So that means I got to get rid of this 3, right? So I'm going to just do this. I'm going to subtract 3 on the right and subtract 3 on the left, right? Now, but watch this though. Be careful, because we can't really subtract 3 from that 8, because that's not really just an 8. That's an 8 to the 5/3 power. So these two are not like terms. So be careful. So you don't combine these and get 5 to the 5/3 power. That would be wrong. So that's what we're not going to do. We're not going to do that, right? We just write them next to each other, juxtapose. So we write 8 to the 5/3 power minus 3 equals x. All right. Then we're going to break this down on the left-hand side and end up with a single number that will be our solution for x. Now, this is referred to as a rational exponent or a fractional exponent. Fractional exponent, rational exponent, whichever you want to call it. We can rewrite this, and then in the way that we rewrite it, we'll end up with a number. Whenever you see a fractional exponent, you know that you're going to deal with a radical sign. You're going to deal with a radical sign. The denominator is the root, and the numerator is going to be the exponent in radical form. So watch this. This becomes the 3rd root of 8 to the 5th power. So that's what you do whenever you see a term. It could be a variable, it could be an integer with a fractional or rational exponent. Look what I did with the 3. The 3 is now right here. The denominator always goes right here. That's going to become the index or the root, right, of your radical sign. The numerator is going to be your exponent. And actually, some people write the exponent inside with the radicand. This 8 is called a radicand. Some people do it, but some people put it outside. It really doesn't make a difference. I prefer to put it outside and deal with the root first and then use the exponent. All right. So again, I want to just reinforce that idea. Whenever you see a fractional exponent, the denominator becomes the root, right? So this is the 3rd root or the cube root. The numerator becomes the exponent outside right here. All right. And then I bring down my minus 3 or my negative 3. I write my equal sign and my x. Now I can simplify this. Right? Using what I know about exponents and radicals. This means the cube root of 8. Lucky for us, 8 is a perfect cube, because 2 times 2 times 2 equals 8. 2 times 2 is 4. 4 times 2 is 8. 8 is a perfect cube. So this term inside the parentheses simplifies to just plain positive 2. So we got 2 to the 5th power minus 3 is equal to x. Now we're getting closer to our result, right? Closer to our solution. Now, order of operations, 2 to the 5th power, that's 32. How do I know that? Because 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So this becomes 32. And then I got 32 minus 3, which equals x. Now I got one last step. Subtraction. 32 minus 3 is 29, and that equals x. All right? But I wanna highly suggest to you, never stop right there, right? When you're solving equations and you come up with a solution, always check your work, right? I'm gonna do my check in a different color. I'm gonna switch up, right? So we check our work. Now, how do you check your work? You go back to the original equation, and then you take your solution and you substitute it in. And if the left side of the equation equals the right side, when you calculate everything, that's proof that your answer is correct. So I'm gonna write log base 8 of 29 plus 3 is equal to 5/3, right? Because that was x plus 3. But I think x equals 29, so now I'm going to throw the 29 in right there where the x was. Now, I simplify 29 plus 3. So now I got log base 8 of 32 equals 5/3. So now, then I rewrite it in exponential form. 8 raised to this power is equal to 32. Now, if that's a true statement, then that's proof that 29 is the correct solution for x. So that means I got 8 to the 5/3 power equals 32. Now I rewrite this, again, fractional exponent. I rewrite it the same way I rewrote this down here, right? So I got 8 in there, 3, and then 5, numerator, exponent, denominator, root. Memorize that. Memorize that. How to break down terms with fractional exponents. So the cube root of 8 is going to give me 2. And then that's 2 to the 5th. And 30 equals 32. Now does 2 to the 5th equal 32? Yes, it does. 2 to the 5th does equal 32. 32 equals 32. So that's proof right there that 29 equals x. All right? And that's an example of how we deal with logarithmic equations. All right. So please like the video, tell somebody about the video, share it with your classmates, share it with your friends. Subscribe to the page, please. Tell other people to subscribe to the page so we can build this up. And as always, do remember that there's all this math all around you. Peace.